I think a lot of innovation is people that are really passionate about something. The innovation that really changes and drives worlds isn't, I need to solve this problem that's bugging me right now and make it incrementally better. It's, let's see how we can push this. Let's see what we can do. My whole vision is I really like seeing what people make. I like growing up and seeing how people are manufacturing and innovating. And if I can empower people's ability to create without the constraints of, I don't know if I can afford to manufacture this, I don't know if I can afford to prototype this, I don't know if I have the skill to, and just have one tool that can make it happen, without all the worries, without all the maintenance, because everything else we've now automated, that's powerful.
Hello and welcome to my conversation with Ethan Baehrend, founder and CEO of Creative 3D Technologies. It's a cutting-edge 3D printing company based here in Austin, Texas, and Ethan is also a great friend of mine. We had a great conversation. This was filmed at his factory, and we talked about, number one, what it's like both being so young in the world of entrepreneurship. His business is in the world of atoms, and mine is in the world of bits with software. But those two paths also share a lot in common, namely educating yourself and not being formally educated, since he didn't go to college and I dropped out to start my company. And we shared and talked a lot about the parallels there, and also the growth that is required when you do something like starting that company, whether it's hiring the first few employees, moving to his factory, and of course, keeping up with the market trends and really making sure you're competitive. So we talked about the personal journey. We talked a lot about his company and what things they're working on, as well as the economics and the macro perspective of 3D printing as a whole. Overall, this was a super fun conversation to have, and I hope you enjoy.
So Ethan, thanks for coming on. I'm super excited to be here in your facility of Creative 3D Technologies. First of all, tell the people what it is and what you do.
Yeah, thank you. It's, great to be here with you as well. We make these really advanced 3D printers that, big leap from your normal one, so throw out all the precognitions of it. But we're excited and finally expanding out here in Austin.
Yeah, so what really got me interested when I started talking with you is we come from super different backgrounds, both in the Chicago suburbs.
Yep.
Both had very unorthodox ways of going through life, of going through our careers, of starting our own companies. And one of the most interesting things is talking to you. You're one of the most knowledgeable people I've met in Austin.
Thank you.
And it's so not attached to where somebody went to school or if they worked at a company, not to mention the sacrifice that's required to do something of this scale, or any scale. It requires, what a lot of people don't realize is a lot of sacrifice, a lot of isolation in both of our cases. So what was that like then back in time when you started getting that initial idea of, I want to start a company? How did you take us through those steps? What was it like progressively saying, okay, I'm going to go out on my own and zig when other people are going to zag?
Yeah, to blaze your own trail and beat to your own drummer. Well, that's always been my general way of things. I've always been unorthodox, and doing that, blaze my own trail, I never really set out to intentionally from a young age, I'm going to start a company. I want to be my own boss, and I'm going to do this specific thing. It's always just really feeling out what I want to spend my time doing. And I think at a young age, I had enough interesting life experiences that helped really give me a perspective on my mortality and how much you really want to take advantage of life. Because my view is, I don't want to be at the point of your deathbed, because I think the worst feeling in the world is to be at that point looking back saying, wow, I wish I did this. I wish I spent my time like this. I regret, insert the rest of the quote. I don't want to be at that point for rest, because when you're there, you just want to be young again. There's nothing else that you wish you would have done then. Follow the things that you're then regretting at that path. So I live my life kind of thinking forward and looking back to, okay, even if this blows up in my face, I know I'm not going to regret it, but I will regret not taking a chance. So when I saw the opportunity and how I can do something that can really change a lot of things but also benefit people, it's a pretty clear path.
That seems so similar to the same conversation I had with myself of going out on my own. In my case, I dropped out of college. I was studying aerospace engineering, but that exact same framing of it, of even if I flat out fail, the
Yeah.
experience itself will be worth it.
Of course.
Knowing that,
it's
you
your
look
own
back.
education, and you're going to get more out of it, in my personal opinion, if you have that very direct, I know that I want to run my life like this, and I want to take that dive. I think if you have the drive and initiative to make it happen, you're going to pull a lot out of it.
For sure. And my curious question, because I know from my own experience how I learned, but in the absence of formal education, there's no course you can take to build a company.
You're starting a path. I mean, you're a pioneer in it.
Yeah, so how did you learn? What was your learning process like? I'm sure it was many things, but I mean, the biggest, hands down, is the internet. For some people, it's reading a lot of books. Mentors are important to a lot of people. What was your process of learning how to do all of this?
I am lucky enough to have started in the industry basically when the industry started. So even though 3D technically dates back to the 80s, I've been in it a whole lot, no, not a lot longer, but right when the patents dropped, I was there. I was involved. I was in it because I had people saying, hey, this is going to come around soon. You already know 3D modeling, you know programming, things like that. You should really get one. You should get into this. And I think that's as close as I've been on the mentor side, because after I'm like, oh, sure, it's going to be cheaper for me to buy this plastic if I want to make nice personalized gifts for like friends, family, things like that. And once I got my hands on it, I realized, I really like making this thing better, using the design principles I know about it and inferring from it, printing stuff to make this thing better, more so than just playing a film, printing the trinkets. And then that started down the rabbit hole. I mean, it was a lot of, okay, let me consult, let me dig through the forums, let me see every single person that's making all these different things for 3D printing and continue to iterate, innovate upon it, and take my own unique perspectives. Because when let's take a step back. If you go to school for engineering, for example, you're not necessarily being taught what to make. You're being taught how to make it. Here are the shapes you can and can't design. Here are the shapes that you can and can't manufacture. Here's the tool that can manufacture them. Here's how you document the process, etc. Now go out into the working world and make stuff. When you have a technology that challenges that, it's very hard to find developers, for one. But you have a lot of, that education that you just spent all that money for, probably paying off in loans, that's really been ingrained. It's hard to reteach yourself when you're jumping into a tech that like, oh, well, all those shapes and things like that, you actually can make now. So if I don't have that knowledge, if I don't have that engineering drilled in, but I have some engineering principles, and then I build my own, and from the very beginning, I'm considering those new geometries, a new way of doing things, and innovating upon that, that's, I think, what really helped set me ahead in a lot of it, because I was already thinking outside the box, thinking with the new shapes, and then engraving that into the things that I was innovating, and then hearing from the others that were also innovating upon it at the same time that, wow, this works and this is good. So it was a lot of trial, error, test yourself, fall, rise again, and see how much better you rise again from it.
Well said. And I think very few people realize how much of all of our understanding, arguably all of it, is trial and error.
Yeah.
And we keep the models that worked, and sometimes they need to be tweaked. But the most interesting thing in my experience when I started going out on my own, building products, solving real problems in the real world, the biggest difference to me in formal education and self-education is that the hardest part in self-education, and I include trial and error in a company, is in school, the hardest part is finding out the answers to the questions you're given. You're given a question on a test, and you have to operate within that box. But in the real world, the hardest part is defining what questions to ask and what problems to solve.
Yeah, and in some areas, you have to be the first to ask that question.
Yeah.
And then you have to find the answer to it, too.
I forgot who said it, but the person who best defines the problem most accurately wins. But I think that's somewhat true in that if you have the best lens and perspective and you're allocating resources at the right problem, then you come out on top. What I'm curious about for you is, when did you realize that there was an opportunity, that there was a problem, you did define it, and then you solved it to then capture value in the market?
I think it was when I made a solution for my previous business to help embetter it, to help scale it, help drive it and make it better. Once I made a solution for that, and I saw the effect when I just showed it off, how people want to buy this not so functional idea on the spot. I saw, wow, okay, this benefits me. I see the value of it, but people are so hungry that they don't even care if it doesn't work, that they want it. This means other people are in the same scenario. Let's see where we can go with this.
Mm-hmm.
And, well, that's set on the path.
Yeah, it's a common pattern that turns out to be useful, that if you encounter a problem of your own and you solve it, it can be a good market opportunity.
The best solutions are the ones that already solve something that you're troubled with.
Exactly. So what was it like going from that one-man shop to then scaling up, hiring your initial team members? Especially at a young age, because I have some of my own thoughts on that transition. But I'm curious because it's something we have in common.
We've had an interesting path. Starting this company, there's a lot of resources already there for me. And I had established and built a really supportive network of people that were saying, the second you can do something that I can venture back, the second you're doing something that I can get more involved with, I want in. And, well, once like, okay, we're going to set down the path and do something that is that exact same structure, it's nice to see that you had the right people with you to help back that up. So even since founding, we had a larger corporate party that said, whatever you need on an as-needed basis, and that's included sharing their team. So even though I was alone, I wasn't lonely. Even though I was the only name on the employee sheet, I wasn't the only one working. And there was always people that, if I needed to ask the right question, I made sure that I surround myself with the absolute best to answer it if I couldn't answer it myself already. So build the right network around you, and then eventually you scale large enough that you realize, okay, more of this needs to be in-house. These partial helpers, these other almost contracted out employees, you need to have full-time working with you here and integrating with each other so then you can really grow. But I realize how many issues in a lot of companies come from not having the right foundation, not having the right base. For example, co-founder conflicts ruin a large percentage of companies somewhere down the line. I don't have the exact stats, so I'm not going to cite it, but it was high and it was above 60. Mm-hmm. And when that's the case, if you can avoid that, it'll take a lot more time, it'll take a lot more effort, but if you can build the right structure in place and do it yourself, you'll be in a pretty strong position. And I figured out, I'll dedicate the time to build out every department, build out every position, build this company to the point where you're not hiring someone to figure out what the position is and build a structure for it, but have it so someone could go and come in, okay, hi, I want a job. Okay, here's what you're doing, here's the structure, here's your process, here's your channels, work. Mm-hmm. If you can have everything that level of prepared, I think that you know how your company's supposed to be run instead of figuring it as you go ad hoc, and I think you can benefit from that. So spending a lot of time and effort to do that, it was rough, but I think it was worth it. And then once it was ready to delegate, we were there. It was all there. It moved faster. So,
yeah, well, your thinking is very advanced, because one of the things that obviously brings us together is we're super close in age, like literally within a couple days in the month. And the age itself is super interesting to me, but also how you acquired your knowledge and what's possible for somebody young to acquire knowledge nowadays. Yeah. So for hiring your first in-house employees, where they're much older than you typically.
Yep.
What was your thought process doing that? Because for me, it was uncomfortable initially, and then I got used to it, of just jump off the ship.
Yeah.
For you, it doesn't seem to bother you. For others, they need a mentor, somebody to hand them
I think that does have to play into my upbringing. I'm an only child. My family always says only child on purpose, saying they want to put the full effort in, and they really have, and I appreciate them for it. There's my shout out, Mom.
There you go.
But in that only child upbringing, a lot of my interactions have always been with those kind of people anyway. People that are high tier, up there in careers, have done a lot, and in some cases, I made it to the peak of success, done really well, and kind of been in that position of regret, like I mentioned, which really helped solidify the reasoning there, but that I mentioned earlier. But I've always been surrounded by them. I'm used to socializing with that crowd. That's how I got my start. It wasn't a jump to go from doing that with people that you've basically befriended to doing that with people that are then working for you. Because in my view is, as long as you can give clear instruction, as long as you're professional at what you're doing, and as long as you're not unknowledgeable or anything, the age doesn't matter so much. Not many people view that. I mean, most people look at me and don't really know that factor either. So it does play to the advantage of some people that might be dismissive of that if they did know the age up front, but it hasn't played against me in any way, and I was just ready for it already.
Well, this specific topic of age is the most interesting thing to me this year that I've been thinking about, definitely in this conversation, which is, you alluded to it, of you just surrounded yourself with experts, people who have been there and done that.
Yeah.
And I look at this also through a historical lens of how many accomplishments were actually done by people in their 20s. Like, what was it? Newton discovered calculus when he was 25. In the 1930s, the number of Nobel Prizes before under 30 years old was at its highest.
Well, and that's when people consider themselves adult. That's when people are like, okay, this is peak career time. And that perspective has shifted as I think age and lifespans increase as well, which has been interesting, but I think it also invalidates a lot of the creative juices and ability that people have at a younger age too, and reserves it for a lot of people that are older.
Yeah, that idea of the question of what input does a human being get fed, how much that determines their life, is super fascinating to me.
Yeah.
Because you can have somebody grow up in, take an ancient Egyptian baby and put them in the hospital today and have somebody adopt them. You would not be able to tell the difference. They would grow up, speak the language, etc.
Yeah.
But you can also have drastic changes where you have somebody, a baby today, get raised by the Spartans, and all of a sudden, drastically different person.
Well, hope you get a baby or something out of it.
Yeah, there you go.
Fed to the wolves, you might get eaten.
Yeah. Well, but that idea is extremely interesting to me, of very closely paying attention to what your input is, and surrounding your mind, let alone yourself, with the right input sources. And I think humanity right now is running one of the greatest experiments of all time, which is what happens when you give an entire generation unfettered access to either the greatest minds who have ever lived. You can listen to Feynman's lectures or whatever. The
greatest repository of knowledge ever created at people's fingertips. How do they take advantage of it?
Exactly. And you can learn every nuanced thing about 3D printing or virtual reality, or even if you're starting a company, find out somebody who's living on the other side of the world and work together on a project that could never happen 1,000 years ago.
No, and all those things are things that people would have deemed miracles at the time too.
And here's the other issue though. That's a double-edged sword, because you have all of the most potent wisdom and knowledge, but you also have the most stimulating distraction ever. And
cat videos
and many other things as well. And my question to myself, the thought experiment I run sometimes, is what happens if Isaac Newton, Einstein,
where would they be
Henry
if they
Ford
had the same resources?
Right.
Who would have defined their times and found the same things?
Yes, or would we never know their names because they just got distracted, or would they become the most accomplished people in human history ever?
I think a lot of it depends on drive. I think a lot of things depend on drive. If you have the want and ability to wake up, want to pursue something, and take every resource, and if it's not there, dig to find it wherever it may be, to put yourself there and gain that knowledge. If you have the drive to do that, you have a lot of power at your fingertips, because you're using the tool that's in your hands properly. And I think that's how I got to where I am. I think that's probably what contributed to help getting you where you are. There's a lot of people that, and when they have that resource, like you were saying, get a little lost in it, because it is distracting, and I think it might sometimes distract and inhibit some of that drive that people might have too. But
I'm curious to know, in your case, if you have any role models. And the reason I ask this is I've found myself learning more and more about psychology, about how people tend to operate, why certain people were successful or accomplished. And a lot of it comes down to either consciously or unconsciously modeling somebody else who's done it. And I'm curious if that was the case, because that can also create, I think, a lot of drive. If you see somebody like yourself that's similar who's already done it.
Honestly, this question's always been pretty hard for me because as long as I can remember, every report, even when I was young, when they were saying, put your hero on here, put your role model, I didn't really have an answer because there's no one that I looked at like, I want to be like you. I want to do this like you did. I'm aspiring to do and become you. I haven't had a want to follow someone's footsteps. I haven't had a desire to take someone's exact path. Will I find influence in certain people in certain areas? Like, oh, I really like how this company or this person marketed this. I like this campaign. Yes, they can influence me in certain areas or certain aspects, but I haven't had someone that, in other than like maybe one to a small handful of regards, that I really saw as like, okay, this is exactly how I want to be. This is who I want to be. When I said march to be my own drummer, there is a bit of a literal extent to that where it really is. I'm trying to blaze my own path and do something new. I mean, some of the technology that we're pushing out closer to 2026, for example, that is something that's new to the point of needing its own definition, needing its own. You get to name an entire industry, which is exciting, but that is truly a new path. That is true pioneering of something new. And who else but someone that could be looked up to as a role model in the future, once that's completed, can really do that. It makes me wonder about how many of the people that a lot of others look up to have been in that same scenario. Because I can name you a bunch of people that influenced me in certain ways, but there's not one good one that's been an overall one that I can really name.
Yeah, it seems like, even in my case, just drawing on people's character and applying it in your own way is the way to go. I want to
take the best from a lot of different folks.
Exactly.
Restyle it to be your own and build it in with who you really are instead of trying to be someone else.
Yeah, so on that trailblazing, that cutting edge right now, what do you guys do that nobody else does? What's your competitive advantage? And then what were you alluding to that's going to be this new frontier in the future?
I can talk a little on it. There's a lot that I can't in terms of specifics. In terms of what we're currently doing, why it's so different, I think the best way to understand is to understand a little bit of the industry, because someone has to see why, and I think connect to why, because a lot of, let's take like the VC sides of folks that I've talked to with startup world and fundraising and that. I think they're used to backing things that are little iterative differences. Oh, I'm not calling out software. I'll harp on software a bit. I'm not calling out you. You're not part of this. But my software company does this little thing a little bit better. Like, oh, our CRM's 5% easier to use or faster, more efficient, whatever. And that's a lot of venture backable because people are like, oh, I know software, I know CRMs, I know SaaS, whatever. This is something that I can relate to, and this is a bit better. It solves a problem. I don't like people saying it solves a problem for a lot of things because there's not always a problem. I view and look back in technology, I think a desire for innovation, a desire to do something better is then after the fact looked at as, oh, you solved this problem. For example, let's look back in a day with cars. I had a better example in the past, but it's eluding me right now, so let's do cars, for example. At the time, I don't think the inventors of the car, the very first one that can be remotely considered a car, were saying that biking is a problem right now. We need something that's better than, if not having something that's better than a bike is a problem. We look at it now like, oh yeah, transportation at the time was problematic. Back then, because it was the norm, that's because it's what everyone had, I don't think it was being viewed as such a problem. I think it was being viewed as, how can we innovate upon the transport that we have? It wasn't a need at the time, but once the tech was there, it became the need. It became the innovation that sparked us viewing it later on as the problem that needed to be solved and was solved. I think a lot of innovation is people that are really passionate about something. The innovation that really changes and drives worlds isn't, I need to solve this problem that's bugging me right now and make it incrementally better. It's, let's see how we can push this. Let's see what we can do. But in that same sense, that's kind of where we were. We were initially trying to make our previous process more efficient. It didn't need to be. Remember, no one's viewing it right now, kind of like 3D printing. No one's viewing what we're doing as a problem, but now that they see, oh, you mean this can actually be done? Yeah, no, this is a problem. We need this. That's kind of where we stand. So 3D printing is, now back to the market that I first touched on a while back. 3D printing is very much where paper printing was, I think, back in the day as an analogy, where you wouldn't really buy a paper printer. You would have a print shop make your piece. They had a lot of different machines. You want your paper to have different fonts? Great. They had a lot of different machines equipped with each and every different font to make it. You want different colors. You want different sizes. For example, if you want something printed on like business card size versus maybe something newspaper size, there'd probably be a different machine to do it. It didn't make sense for you to own all of them. So instead, you had someone else do it. And then eventually there's paper printers that brought most of the print shop into one machine, and now they're kind of everywhere. They're in most offices, they're in a lot of homes. 3D printing is very similar. There are very literal print shops nowadays that have all the different printers. You want your plastics big enough to print something like that chair? Great. There's a large format printer that lays down a large, imprecise bead of plastic, and that's like the one thing that can really make that kind of part. That same printer doesn't have the precision or tolerance to do something that has better precision and detail than your fingerprint, because that's a detail printer's job. And remember, these are just for plastic, because if you want those two functions in a metal, for example, completely different submarket. So you have the plastic submarket, you have the metals. Then you have to know, okay, well, which metal? You want stainless steel? Great, you're buying a really expensive machine that needs all these other machines to go with it just to make it work. And then you realize, oh, well, this printer can only do steel. And if you ask the company, like, can it do titanium? You get the salesman question of, why do you want to print titanium? Instead of saying that they can, they ask why, because that's another fragment of the submarket that someone else fills and someone else does. And then the list goes on, and from different materials, from like your fibers, your foods, your paste, your ceramics, you want different resolutions, or hell, if you want different features, like, oh, I want this thing to have like IoT and Industry 4.0 connectivity and be ready for the future of manufacturing, that's something else that defines its own printer. And it doesn't look like it from a first glance, but competition's a lot less frequent. You want large parts for $50,000, there's a very small handful of companies that sometimes you can count on one hand. And they're the only ones that can produce it. You have a $70,000 budget, you have a $30,000 budget, very different sect, very different subdivide. And that's why there's print shops, because it doesn't make sense for someone to own everything. Just have someone else do each individual thing. And you said, oh, I want a metal part, I want whatever. They have the tools to make it happen. We are that all-in-one shift for the industry. You want a bit more of everything in one piece, and you can have all that capability in one tool that costs less than any of them. Might as well. I mean, we don't fall into the multi-tool problem where, say you're on an island and you need to cut something. You only have a Swiss Army knife. You're wishing you had a real knife right there to really cut through that versus the knife. Usually people think, oh, but if you're a multi-tool and you're doing a bit of everything, you're a generalist. You must be worse than a specialist. I think it depends how you approach the problem. We approach it from a completely new set of engineering standards and design and production standards that really helped enable us to not only be cheaper than any one of the many units we encompass, but individually outperform them all in their own subsect and their own specialty. So where we come to market is we do an entire suite of 12 plus separate specialty printers, do all on their own independently, all in one tool for a fraction of the cost of competition. We're in a unit that's it's sub $20,000 for a unit, well, in our units, outperforming what would typically cost upwards of $1 million in terms of the entire suite of tools that you would need to get close to what we're doing. Even though we're least expensive overall, we're cheaper than any of those units individually. You want metal, for example. I can go down literally 12 different direct comparisons. We'll just do metal. Machine costs were 99.99% less expensive. The current metal printing processes have a lot of waste. If you don't use certain powder in your metal, if it's not heated, it's not part of your part, there's close to like a 50% waste ratio. So all the metal is not used a lot of times, and you can't recycle all of it. The ones that can't be recycled, that's waste. We're only printing what we use, so we're more efficient by a large percentage. We can do complex structures that others can't do because we can do true internal structures versus the metal ones. If you have just loose powder that hasn't been bound together in there, you can't do an internal structure. Our cost per gram's more than 30% less depending on what metal you're trying to print, and we can even mix certain metals in the exact same part. If they have similar post-processing coefficients, because we turn like what would typically be a 7-step process into 2 steps, if you print and you basically put in a high-powered oven, if they have similar temperatures in the oven, you can actually mix multiple metals in the same part. And again, that's all a tool that costs that much less and is able to do way more than just one type of metal. So we're cheaper, better, and even if people don't care about like 11 different types of printing and just want that one, we're still the best option in the industry. But it's also a long-term platform, so even if 5 years down the line you want something better, great, your tool's capable because we built it to be a platform that's so powerful that just swap the latest tech on and we have the capabilities to back it. We have the precision, speed, tolerance, UI to keep evolving and growing as the industry does.
Yeah, that's a powerful thing. So you have utility and price going for you and the platform that other people can build on.
Yes.
And that's real interesting what you said early on, which was the R&D side of things and innovation versus the marketing of where's the problem, let me solve it.
Yeah.
Just innovation, building something that's objectively better where there's almost an infinite number of uses for it, and it's just up to the creativity of others to make it happen.
Yeah.
That's very fascinating. And
that's been the dynamic, and when there's less direct competition, you don't really need to innovate because you're in one niche selling to one kind of customer and there's little to no competition. You can keep prices high, quality low, and just incrementally innovate. I give the phone industry example. We haven't seen too many massive leaps. You'll see generation over generation like, oh, well, software, this doesn't include software, like hardware-wise. Oh, we threw one more camera on and this is now 5% faster. That's not a leap. That's an incremental change. It's an incremental difference from the last one. That's all people have done because they view it as, well, if we don't really need to compete, and why reinvent the wheel? It's really hard for someone to do this if you're stuck in the traditional manufacturing processes, unless you take a lot of time and effort we took to get here.
Wow. And you alluded to this, but I want to expand on it. The benefits of 3D printing another object versus traditional manufacturing processes, whether it's eliminating waste or something that's very interesting to me is most efficient structures where the AI will optimize and it almost looks like an organic
Yeah, you tell it, I
structure.
want these faces. It's called topology optimization. They optimize the shape of it. It'll look alien sometimes, but hey, I want a 1 inch by 1 inch flat surface. I want it to be 1 foot tall and have a flat base. Figure out the rest. It'll make the most efficient thing that has that base and that top. And it usually doesn't care about if it's manufacturable or not, which 3D printers are really good at making because it expands that skill set that we talked about with engineering of what shapes you can and can't manufacture. It opens up a lot of new doors.
So with these crazy benefits of waste elimination, having this general purpose platform, who does this threaten currently? Economically, whether
it's disruptive to the current industry dynamic because, well, again, I mentioned it was subdivided. It's divided into different functions of printing, different specialties, different sub-markets. We have a product that ignores those market dividers of function because it's relevant to all of them, and versus some very niche cases on certain ends, and it eliminates the problem of price because I see there's like 3 main markets in 3D printing. There's a sub $6,000 consumer. It's a while away from being an everyday consumer technology because, well, the reason why everyone has a paper printer is because we all know how to use it. You have the ability to think of something that you want made and not just Google and hope you find online, but you have the ability to make it. You can open up Word, you can type up a document, you can make a PowerPoint, you can click print, and the thing that you envision in your mind is now on paper. Till 3D printing's there where someone can imagine whatever they want, not just search for a model in a repository, design it, then click print and have it be finally done. Until 3D modeling is that ubiquitous skill, or until a giant like, for example, an Amazon jumps in and makes most relevant consumer products printable, so then someone can end-to-end manufacture that full product on a printer, like your Star Trek replicator. That's a little bit tough. So we're not quite there, but right now the consumer is your hobbyists, some startups, your Etsy shop in the garage. There's a couple of crowds like that, and they fit in within that price point. There's the sub $50,000 middle market, which is where I see most of the development and movement. There's your small businesses, medium businesses, some on the large side. You'll have your research labs, your prototypers, your machine shops, and some of your universities. You get a bit of everything mixed in there, and they'll buy different quantities of units depending on their need. And then there's the 50,000 plus industrial market. That's composed of some of your DODs, your world governments, your automakers, the bigger industry that's buying a lot of these. The price that differentiates them is, well, given that we're doing a couple 100,000 and even outperforming some printers that go into the million mark on a unit that we're selling for less than 20, it really breaks down a lot of that barrier. And my whole vision is I really like seeing what people make. I like growing up and seeing how people are manufacturing and innovating. And if I can empower people's ability to create without the constraints of, I don't know if I can afford to manufacture this, I don't know if I can afford to prototype this, I don't know if I have the skill to, and just have one tool that can make it happen, without all the worries, without all the maintenance, because everything else we've now automated, that's powerful. So making it accessible is big, and that's where it starts to get dangerous, because you're not only disregarding the function divide, but you're also disregarding a lot of the price divide. You're making products relevant to basically more than 60% of the industry. That affects everyone's little niches and how things have been operating so far. And this is a product that's really hard to compete with, because a lot of the ways we make it is using trade secret production tools that we've made in-house to make the very specific parts that are crucial to this thing's function. Not only would you have to figure out how the hell we designed the thing, then you have to design it, and then you have to figure out how we made the part, then you have to make the machine that made it, and then make the unit and hope it works, which is why it took us like over 200 iteration cycles just to get the thing right. So we're competing against anywhere from your industrial market competitors to most your mid-market. We'll see some on the consumer side, and we'll do it better than a lot of them. And it's a long time span for them to be able to compete, because the way to do it is you have to make some of that stuff in-house. There's no way around it, because I've had manufacturers in Asia say, you're crazy if you think this thing's manufacturable. So we did in-house, and trying to even develop, well, because it's so new of an industry, there's no standard of what parts should be in a printer. We're using parts from like CNCs, for example. There's a standard for CNCs and how their ball screws are supposed to be made. And then trying to redevelop that standard, because a ball screw is something that moves up and down. It helps give you linear motion in a machine. There's a standard for how that's done with a lot of other tools, but some of it's relevant to a 3D printer, but it's not the best solution. So if you redesign the ball screw, change how it's made, you still use a lot of the same tools to make it, but it's a completely different process. To invent that process, that's tough. To develop the standard of what should be used in these machines, and as you develop your printer, not care about how anyone else has done something, because you're really trying to not reference the other machines that are problematic in nature already, but do something that's completely original. It's a really tough process to really compete with that. And as the market's growing at a 30.2% CAGR, as long as we scale fast enough, a lot of the people that are buying their first printers, they see, oh, well, this thing's the best deal. It's being used in all these massive companies. They build a reputation. It works and does what it says they do. I think I want that. And so the more than 10 times more expensive one that can do like this one function and potentially set on fire.
Yeah. So you have that competition between other printing companies that make these.
There's a lot of individual competitors. Like there's direct individual competitors for each of the 12 functions, but we still outperform them.
What about competition on the macro level of a means of producing something itself? So 3D printing competing with other manufacturing
Completely different
processes.
technology.
Or say something that's getting built in China in volume, competing against that and being able to print it here quickly. Is that a competitive element at all, or are they in different ballparks?
You're diving into an interesting topic. Let me help define something first. There are 3 different manufacturing processes. There's a jobbing process, which if you look at the graph, it will be at the bottom of the graph, where it's very inexpensive to get into, but the cost rapidly goes up at scale. For example, if you have, say this is your print plate, and you can fit like 50 of these vases on here. That's a bad number, probably 20. 20 of the vases on there. If you have a normal 3D printer, you are having one 3D printing head print 20 vases. And it's going to take the same amount of time, whether they're all clumped up on the bed or you print them sequentially one after another. So your costs get pretty high at a more scale, which is where something like batch manufacturing comes in, where you're having decent amounts of volume, but you're manufacturing more than one product at once. You're making a batch of pieces at the exact same time and pushing them out. It's more expensive to start at, but it's better for some decent scale. And then there's the mass manufacturing process, which is what China has locked down, where it costs a lot to get set up, make the molds, set up the whole production line and system. But once you do, for mass quantities, it makes a lot of sense. It's really affordable. 3D printing is stuck in that jobbing process right now. Our company turns into a batch process because we're able to make multiple of the same piece at the same time, and we can do that sequentially, where you make multiple pieces, move over, start another few, and basically you walk in the next day and you can have version 1 through 10 lined up on a plate ready to go in quantities of each. We start to bridge that gap and turn it into a more efficient process, and then that 2026 unit that I talked about too, it's still a batch process, an autonomous batch process. But I can do so cheaper than a standard manufacturing process for an entire fully finished product. It's really hard to compete with them in terms of single part cost, but the more steps that are needed after that you have that part, whether it's assembly, whether it's painting, coating, polishing, other machines, other plastic parts, other electronics, all these other things that need to go into it, those machines all cost a lot of money. The packaging, the assembly, the whole factory has to account for all the steps and all the money that's going into making your product somehow. So they're going to factor that into the product cost when they sell it to you. And then it still needs to ship. It needs to get to someone like Amazon. So when you as a consumer goes to buy that product, there's all of these things that have already been added on. If I can make you that same product, make it qualified, because we've been able to self-qualify and we know exactly how much material is supposed to be output, how much is actually output, and if it actually fits, and cross-compare it to your design file, and we can take all those different machines that all cost from maybe a couple $100,000 all the way up into $100 million, do it in one machine that we can sell for, sub $200,000, and make that full thing end to end, and you can have these machines wherever you want and be able to make the exact same self-qualified part. The more complex, the more steps it takes to make that thing, the cheaper my unit becomes compared to that. So I can't beat them in cost per part, but for a cost per final product, that's where things really get interesting later down the line. That's where I'll be competing not in volume, but in cost per product, because think of it, if you can recoup the cost from it, you're going to buy more of these machines to scale that process instead of outsourcing someone else, because you'll be making more money in even the midterm.
Wow. So that's very interesting. So as you add steps to the manufacturing process, that's when you become more competitive.
Because all of our steps are built into one.
Okay, so my next question is...
Little factory in a box.
Yeah. So would you ever have a factory of just a ton of these general purpose machines? And forgive me, I'm not familiar with the other kind of, it seems like...
It's like trying to touch on something without too much detail.
So like integrated circuits are purpose-built. You can't change them after, but they're highly efficient. When you disregard generalization and freedom for something specific. So my question is, if you were to have, say, a factory of all these general purpose 3D printers that can perform
legally
competitively...
needs a different definition, so it's technically not a printer.
Yes, so... Well, yeah, that's when it gets interesting, because the question that I have is, how much work is it, say, for a factory that makes a specific product to retool itself, to just change what it builds?
Send it a different file.
Yes. So for you, which is,
Yep.
But what is it right now for, say, a company that's
a lot of money?
Yeah.
Because that's the process right now for going to concept the product is you design it, you pay a lot of money month over month for a simulation software, which would probably cost more than some of our units to begin with, to simulate and hope you build the right environment that simulates everything, and then you keep simulate, so you have a final product. Then you pay a lot of money for tool up, which, depending on the complexity of the product, depending how many steps are made for it, can be really intense because it's optimizing assembly stations, it's making molds for all these things, it's getting the right paints, it's getting everything equipped. If you then start to push out your product and get in people's hands and something goes wrong, the cost to go through that whole process again is a lot. And if you can change that and just like, oh, here's my idea, print, oh, here's the fully finished product, same tolerance, same features, same everything else, design, print till it's done. Have that tool that you just use to do that be a recurring source of revenue for you. So as say it's a startup, you're not losing out, you're not risking going under because you're gunning at an idea that might seem impossible. And then once it's done, and once, for example, like we approve it, then every single person with that machine across the world can make the exact same thing. That really changes that whole process. That makes it a lot more efficient. And it can make it more custom for anyone that wants that product that person just designed. Because you can tailor it to you just as easily as making whatever that standard version would be.
Wow. And I would assume you also get the benefits of rapid iteration. If you have a new version on software, okay, you just push an update. But in hardware, you need to move atoms in the real world. But
Well, that's why we designed modularity in mind. We want anything that we make, we want to be relevant for a long-term span.
Mm-hmm. Okay, so now my question is, when people think of 3D printing, they think of simple objects, trinkets, things like this. But
little printed toys that everyone has.
Right. So how far can you take this? You mentioned metals, electronics.
Sure. Yeah. Currently, it's with the 3D printer that's out right now, the new one that we have at least coming out in March. So we can discontinue the earlier one we had out after it did pretty well. Now the sequel's coming, but that one's capable of doing basically if we can get in a powder, we can get in a paste that needs to be either heated or cooled. If we can get in a plastic or something that can be melted, we can work with it. So it opens up a lot of potential. We don't limit our customers, so anyone that wants a machine, if they want to go, I want to try this thing out. I want to test this material that's not on their docket. If they want to just test it out, we're not going to limit anyone, but if someone wants kind of that plug, play, select a material, click print, all the same steps you would do to request that from a print shop, we can make it print shop levels of easy because every other process that would go into running a printer has been automated.
What new kinds of things can you manufacture in terms of utility and function that you can't do today? So rather than say...
It's more what shapes. I think we have yet to really take advantage of a lot of the in products, in new systems, take advantage of a lot of the new geometries that we can make. So all the products we have in our everyday are still limited or kept in mind with the traditional manufacturing set of geometries you can and can't produce. I'm really excited to see where products go within the next 5 years even, as this technology becomes even more and more efficient and more widespread for people to really push that barrier and make even more interesting pieces. I can go over shapes and what can be made, but not as much new things have been made, but a lot of things have been optimized. There's a lot of parts that have been redesigned, had the computer topology optimize them, so it's 30% lighter but 50% stronger. We're improving current products and parts, but a lot of the new wave of products and parts hasn't started yet, in my opinion.
Well, yeah, you mentioned metals, being able to print with metal. Ostensibly, you could print wires and circuitry.
We've done printed circuits in the past.
Okay, so what can you print motors? What can you do with this?
Well, motors, because it involves coil winding, is a little bit different. So the way that we attack that with the 2026 machine, because that's something that needs more manufacturing steps than just printing. We've got some interesting routes on doing so, but the thing's modularized. So we start to identify what machines can produce what, and when the customers want to order different objects, we can see, okay, in our network, this machine's equipped with this and has these materials in it, we can make this gamut of products. So if someone has a module that we want to make a module that makes motors, someone can buy that module, equip it to the machine, and then that will be capable of, basically, you give it its raw inputs, you give it its copper wire and its other metal dust and the magnetic dust that go into it, and then that unit, if we're talking hypotheticals, we would then go from, okay, it would print out the part, grab it into the next module, it would do the windings on it, bring it back, print out the metal pieces, grab it, sinter them so you're left with a full metal, bring it back, and that unit on the side will do the whole assembly, give it the motor, then put it into a slot where the pick and place starts to, okay, as you build up, say it's like a drone, you have your little pocket, drop in your motor, and then cover it, encompass it in, and then without any assembly, you just put the drone's motors into the drone. And then we can go in with silver ink or actual copper, identify the pins on that motor that we just made, and then put wire on the layer and then cover that layer, so now you just did the wiring step. And the whole idea is, if we partner with a lot of different companies that are already doing something that's 2D, they haven't brought 3D yet, we can enhance their capabilities. If we build the right module for time motors, we can potentially make windings on all these different dimensions that no one really thought of, because we're not limited to a two-dimensional manufacturing process. You can bring it upwards. Or circuitry, we've messed around in the past with printing onto different surfaces that weren't just flat, so we were able to take different circuits that would typically be flat and compress them into cubes, for example, because we can go upwards with the tracings. And basically drop in your chips, print them, wire them together, layer down some things of plastic with a hole in it, so then you just kind of fill that in with a little bit more metal, and then add those layer by layer to go upwards and place things in weird ways and start to push that technological barrier.
There's so many moving parts to it all that
it's a crazy assembly.
Yeah, well,
it does not fit in most doors.
Well, the interesting experiment to me would be to say, here are all the materials that I can print with, here's the printing space, here's what it can do, and feed that to an AI of sorts and say, produce the most useful design possible that provides the most value.
Yeah, have it think of what people need, and then have it decide, okay, this is a product that people need, and here's all the shapes we can use to make it, and what we don't have barriers. Maybe we'll involve some of that.
Yeah, so where do you see the entire industry going? What does the lay of the land look like?
I have two answers for that. It depends if we're successfully able to influence it or not. If we're not able to, I see it's trending towards, at least 3D printing industry, hyper-specialization, where you need one specific printer to print one kind of product and one kind of material for one customer. And it gets pretty polluted if a lot of different companies on the industrial line. Consumer end's one thing. We lost our light. Consumer end's one thing, where the consumers are all... There's a lot of knockoff printers that are all one similar price, making this basically the same printer over and over. On the industrial end, it's really different, where I think it would be hyper specialized, where one printer does one function by one company at one price point, and make the print shop even stronger. Versus if we're able to have an impact, I would like to start to move this technology to be in more and more businesses, benefit them, eliminating those constraints, and start to dissolve the need for the print shop, or have the print shop be a lot more efficient by using something like us. And the late future, have manufacturing as a whole be decentralized and distributed to anyone that can have one of these platforms. So then you don't need to wait the lead times, you don't need to worry about the infrastructure and the supply chain, which is going to affect a lot. But having these ever able to create most products, it's not magic, it's not going to be able to do everything. But a lot of things, be able to decentralize and distribute that, so even if you're in third world country, as long as you can receive the material and you have power and you can have the same level of ability that someone anywhere else can have, as long as you have that, that's exciting to me. So that's the effect I want to have.
Well, that's phenomenal. And before we wrap it up, I want to read one thing that I
Sure.
swiped from your LinkedIn, and I want you to comment on it. And it was remarkably put. You put it on the. You mentioned it in the beginning briefly, but it bears repeating, and I want to get your thoughts on it.
Sure.
Quote, Ethan Baehrend, I live my life by visualizing myself in the future and how I'd be looking back upon my present self. I picture myself upon my deathbed whenever that might be, and I imagine what regrets and realizations I'd have on that day. Maybe that the point of having a long life isn't to put off your actual plans until tomorrow, but rather to give you more time to pursue them today. Or that the route of most personal fulfillment will bring risks, bad days, and stress, but that will be nothing compared to the misery of realizing my entire life had been wasted on doubts, self-sabotage, and fear of rocking the boat. I think that's what stops most people, is fear.
Yeah, I've seen that a bit, and that does actually, that quote involves a lot of different, my own quote involves a lot of different quotes that help build that one too.
Mm-hmm.
But my thoughts on that?
Or any closing remarks for somebody who's maybe young, looking up to you, saying, wow, he's doing all these amazing things, I want to make my mark, or at the very least, have no regrets and be willing to rock the boat.
Well, at least my thoughts on a quote to include the first question first. I think I've lived pretty true to that. I can comfortably say, if whatever happens, say I'm realizing like right now, today's the last one. I'm disappointed I couldn't see some things through. I'm not regretful, and I'm comfortable with it. And definitely want more people to be in that position. I think, especially a lot of young people, if you have something that you want to pursue and you have a really good route to do so, there's always going to be excuse on why to put it off. And the traditional system that we're in is always going to tell you, for example, if we go back to when I starting, oh, well, you need to finish, with the first business, you need to finish middle school first. You need to finish high school first. You need to finish college. You need to get a job first. You need to build a financial backing. Oh, well, now you have a house. Now you might have a family. You need to support that. You need to, basically the only time that you have time, you have the resources, and you have the time to pursue something is when you're retired, when you don't have any energy to do so. When you're young, you have a lot of energy. You don't have the other two pieces. If you know you're going to regret it later on, go for it, because think of it, you'd rather fall on your ass now and get up from it now than later on when you can't afford to do so. Take the risk, take the chance, see where it takes you, and know that even if it screws up, you tried. So, go at it.
Perfect way to end it. Lastly, Ethan, where can people find out about you and your company?
Look us up, just Creative 3D Technologies, or on a lot of our social handles, Creative 3D Tech. We've got a pretty exciting announcement coming on March 9th.
Excellent. I'll link it in the description.
Thank
Ethan,
you.
it's been a pleasure.
Been a pleasure.